Hi, and welcome back to Null Zero Labs. Today we are straight in the lab, mainly because I want to test and try and solve an issue that I have with a VPN between a Palo Alto, surprise, surprise, and an old school Cisco ASA. Now, the issue lies in the fact that the ASA wants the VPN to be a policy-based VPN. And the Palo Alto would prefer it to be a route-based VPN. I also would prefer it to be a route-based VPN because it gives us a bit more scalability. It allows us to act just solely on routing. We have a lot of subnets that are being routed across this tunnel. So in this lab, we're just going to go through getting a VPN configured on the Palo Alto side, and then we're going to configure a VTI, a route-based VPN from the Cisco ASA side, and check that we can reach the subnets on either side that we need to, i.e. 168.1 and 168.2. And then we're going to add another couple of subnets on either side of those as well, and make sure that those are traveling through the tunnel via a route-based option instead of a policy-based option. Because on the Palo Alto, when we do a policy-based VPN, we end up under our tunnels having to apply these proxy IDs. And when you've got a lot of subnets going backwards and forwards, having to add all of those proxy IDs onto each of those tunnels that require it can be a bit of a pain. So if you haven't already, hit that like and subscribe button. That'd be greatly appreciated. And let's jump straight in with the Palo Alto side and get that configured, because we've done that before. And we'll test that our local router here can reach the Palo Alto and that we have reachability to the internet. And then we will then do the same on the ASA side, and then we will start this process of configuring the site-to-site VPN side. So let's start with the Palo Alto because it's the easiest side and we've got a nice GUI to start with. So let's jump into our interfaces. Now, inside is 1/2, outside is 1/1. So let's start with 1/1. We're going to create a layer 3 interface. It's going to be part of our default router. I'm going to create a new security zone. We'll call this one outside so it's easy to follow along. So that is the outside interface. It's going to have an IP address of 203.0.2.2. So 203.0. What do we say? 2.2. /30. We'll need to waste IP addresses. So that's our external IP address. Security zone default router. We will just allow ping to that outside interface just for our testing purposes, so that we can ping it, make sure it's reachable. That should be the outside interface. The inside interface, again, is going to be a layer 3 default router. We will create a new security zone. We'll call this one inside for simplicity, so that we can see what we're doing. The IP address on this side on the left is 192.168.1.1/24. And again, we will just allow ping on that interface so that we can test. So that's our two interfaces. So that gives us outside interface, inside interface. We're going to also need a default route. So let's go to virtual routers, static routes, add, we'll call this the default. And that's 0.0.0.0/0. And that's going out of E1/1. And the gateway hop to the internet router will be 203.0.2.1. 203.0.2.1. So inside interface, outside interface, default route. Next, we're going to need a policy. So we're going to allow our, let's call this our internet rule, where we're going to allow our inside interface with 192.168.1.0/24 access to the outside interface with any address, and we'll just allow it any for our testing purposes. Next, we'll need a NAT. So we'll add a NAT. So we'll call this our SNAT. And this will be from our inside zone to our outside zone with a source address of 192.168.1.0/24. And we will translate that to our outside interface address just for testing that it can reach the fake internet zone. Okay, so that should be everything we need to get the ASA connected to the internet. So we'll commit that. Whilst that's committing on the internet gateway, I'm going to put a int L0 IP address of 8.8.8.8. That will be our simulated Google DNS address point. So traffic coming from the inside should be natted to the outside interface, so should be able to reach our test point on there to show that our configuration for internet access is all functional. And that's committing. So let's jump onto RTR4, and we should be able to do a show IP int brief. So all we've done here is configure an address on this interface of 1.10. We've got a loopback address that we're going to try and reach later. But for now, we just need to ping 8.8.8. There we go. That's committed. So we'll double check on the monitor, traffic flow. We should see, we hit refresh. Send some new traffic. There we go. We can see from our inside zone with a source of this address went to death. So this part of the configuration is functional. We have a Palo Alto online and its clients behind it can reach the internet, the very basics of what we need before we create a VPN tunnel. So now let's jump on to the ASAV, and we're going to do a similar scenario. We're going to set up the outside interface, the inside interface. We're going to set up the default route, make sure that we've got a NAT so that the traffic from the inside network can reach the internet and reach 8.8.8. Then we're going to start this tunnel configuration and make sure that we can get VPN traffic across the internet and across the two sites without having to add any proxy IDs on the Palo Alto, because yeah, that's been a royal pain. So let's show IP. No interfaces configured, no IP addresses. So int G0/0. So its IP address is going to be 203.0.1.2. And I've used a /30 address for that. The interface name, well, the name interface is going to be outside. And security level, we will hard code it, will be 0 because it's a public interface. And we will no shut that because that should be enough for the outside. We will do int G0/1. That'll be our inside interface. So name, and we'll call that inside. Its security level will be 100. And its IP address will be 192.168.2.1/24. And we will no shut that interface as well. Now we'll do a show IP. Outside interface, inside interface. Next, we're going to need a default route. So a route to the outside. All traffic, that's going to go to 203.0.1.1, which would be this gateway here. And next we will do a NAT. So we will create a object. Will be the easiest way. So object network, and we will call this inside net. That'll be a subnet. And it was 192.168.2.0/24. And then we're going to want to NAT that from the inside to the outside. And it will be a dynamic interface again. And because we are doing security level 100 to 0, that should allow that. We probably need to the policy map, which was the global uninstall policy. It's a pain having to do this via the CLI because it has been so long since I have had to touch a ASA CLI inspection underscore default. Yep. And we will inspect ICMP. That should be enough to get us to test from router 5. And again, show IP in brief. We've got 2.10 with a default route to 2.1. So let's ping 8.8.8.8. There we go. So both of our sides of the connection have got the basics of internet connectivity. So next, let's configure the required VPN configuration on the Palo Alto side. And then again, we will jump onto the ASA side and we'll check the traffic flow. So we're back on our Palo Alto. Let's start with the network section. And let's start with a couple of profiles that we're going to need. So let's look for the phase 1 profile. I'm going to call this ASA-phase 1. Now the phase 1, we're going to do Diffie-Hellman group 14. The encryption will be AES-256 and we'll use a SHA-256. And for our seconds, I'd like to do 28800. Okay, so that will be the phase 1 that we're going to use. Phase 2, crypto map, or however you want to, IPsec profile. So this will be our ASA phase 2. It's going to be ESP. Again, encryption will be AES-256. And we'll use a SHA-256 again. Lifetime will be 3600 seconds. Now, this is where the gotcha is going to be, because on the ASA, and after many an hour looking through the documentation, on the ASA side, when we are doing a route-based VPN, the Diffie-Hellman part of the IPsec profile, there's no option to set that for the phase 2 manually. It adopts it from the phase 1. So because we have set on the ASA side group 14, the ASA is going to adopt that when we send it from this side. So I was setting it up saying, hey, no PFS or none, which wasn't compatible, and the tunnel was never coming up. So we're going to set it as group 14, but even though we're not going to set it on the ASA side, you'll see that the tunnel will come up because the ASA will honor the fact that we're using Diffie-Hellman group 14 because it's going to adopt that based on the phase 1 for its side. A bit odd, but it works. We don't need to do anything under there. So that's our 2 phases that we're going to use. Let's create our gateway. So we're going to go to the public IP address of the gateway, which will be 203.0.1.2. So we will call this the ASA, call this tunnel VTI 10 gateway. So what we're doing, it's going to be a IKE v2. We're going to use our outside interface, and this will be our address that the tunnel will be coming from. And we want to connect to 203.0.1.2, which is the public IP address on the ASA side. We will set a pre-share key. I'm just going to use not password. And for the local identification, we will use the IP addresses. So from our side, we are going to identify ourselves as 203.0.2.2. And the peer should identify itself to us as 203.0.1.2. We won't worry about the passive mode because both sides of the tunnel can come up depending on who wants to bring the tunnel up. Don't have to worry too much about NAT transversal at the moment, but we will set our ASA phase 1. So that should be all we need for the gateway. Next, we need an IPsec tunnel. So basically phase 2. So we'll call this VTI tunnel 10. Hold on, what did I call that? VTI 10 gateway. So we'll do VTI 10 tunnel. We'll just call it VTI 10. And the tunnel interface will create a new tunnel, tunnel 10. And it's going to be part of our default route. We're going to create a security zone for it. We'll call this VTI 10. And we're going to give it an IP address. We're going to put a tunnel IP address on our, we're going to put an IP address on our tunnel because that's what we're going to point to say that this network is available via this tunnel address, and these networks are available via this tunnel address. So let's do a 169.254.43.1 for this side. Don't need to worry about allowing ping on the interface. Default blah blah, that should be a good. And it will be bonded to the VTI 10 gateway. And we are going to use ASA phase 2. Now you can see I'm not going to put any proxy IDs under here. And I've got a firewall at the moment that is full of proxy IDs, and it's a nightmare. So that should be all we need to do for the tunnel. So we've got our tunnel interface, we've got our gateway, we've got our phase 1, our phase 2. Next, we're going to need a route. So under static route, we're going to say that 192.168.2.0. So 192.168.2.0/24 is going to be available via the tunnel interface. And the next top IP address is going to be 169.254.43.2. So that's our default route. Don't need to worry about NATs. So next we will do a policy. We'll add one at the top, and we'll start with VTI 10 out. So from our inside interface, we have a source address of 192.168.1.0/24. and go to the destination of the VTI 10, and it can go to 192.168.2.0/24, which is the remote subnet. And we will just allow any application for the time being. Going to move that above the internet rule. And we will be very specific. We will clone this and we will create an inbound. So VTI 10 in. So the source this time will be from VTI 10 with a source address of 2.0 to the inside interface with a source address, a destination address of 1.0. So that should allow traffic from the left subnet to the right subnet and from the right subnet to the left subnet. So let's just commit that and we will double check what we've done. So we've created our phase 1 and phase 2 crypto map, and we're going to put that on the ASA side. We created our tunnel interface, VTI 10. We gave it a link local address that we're going to use as our point for sending the routes out. And we've put a policy in place to say, hey, if you're coming from this network 1.0/24, you can access this network 192.168.2.0. So that's going to commit, and then we will be able to watch for this to come up once we configure the ASA side. So let's just check that that's all correct. The local side, peer side, we did that, we did that, we did the route, got our security zone, and we've done our policy. So that should be everything for the Palo Alto side. So now let's jump back onto the ASA. Okay, so now we're on the ASA side. So what I'm going to start with, I think it's easiest to start with all the crypto stuff. And I've got that written down here because I never remember it. So we're going to start with a policy. So we need a IPsec policy, so crypto IPsec. And again, it's going to be IKv2. And we're going to create an IPsec proposal. I'm going to call it the Palo proposal. So that's that. And the protocol is ESP, that's correct. And we're going to use AES. ESP, and the encryption is going to be AES 256. And then the integrity is going to be a SHA 256. And yeah, because this is basically the phase 2, you can see that we don't have any option to set perfect forward secrecy or a DH group. So we'll set that on the phase 1, and this side will adopt it. So that's what the documentation says. It works. I have checked it. So that's good. So we've got our proposal. Next, we need our profile. So our crypto IPsec profile. And we're going to call this the Palo profile. And then we are going to set the IKEv2. And we're going to set that to the IPsec proposal of the Palo proposal. Proposal. Make sure I spelled that right. And that should be it for the profile. Now we will do our phase 1, which will be our crypto IKEv2. And this will just be a policy. We'll call it 10 to match with our tunnel interface. It doesn't have to, you can give it a completely different number, but hey. And its encryption will be AES 256. The integrity again will be SHA 256 we will use group 14, and we will use perfect forward PRF of SHA-256. And the lifetime we said was 28800, about 8 hours. Next, we need our crypto IPsec security association lifetime in seconds, 3600. This is where we set the phase 2 lifetime. And now we'll enable crypto IKEV2 on the outside interface. And I use the capital. Next, we'll create a tunnel group, and we will get the tunnel group will be 203.0.2.2. That's the public IP address of the Palo, and we set the type will be an IPsec site to site. We will set the attributes, and we will set an pre-share key. The remote authentication will be pre-share key. I just set it as password, and then we will set the local authentication, pre-share key, and again password. So we're sending password if we can, and they're sending password. So that's the policy done. Now let's create our tunnel interface. So int t10, and we will name this interface as VTI10. Its IP address will be 169.254.43.2, 255.255.252. The tunnel source address will be the interface outside, so the public IP. The tunnel destination address is going to go to the Palo Alto's address, which was 203.0.2.2. And then the tunnel mode is going to be IPsec, and it's IPv4. And the tunnel, and we want to protect the tunnel with the crypto that we started. So tunnel protection is going to be IPsec profile. We called that Palo profile. Was it Palo-profile? Palo-profile, I think it was. We'll soon find out when it doesn't come up. Palo-proposal. Palo-profile. Perfect. So that should be it for the tunnel. Next, let's create some rules. So access list, and we will start with inside to VTI 10. And for simplicity, we're just going to set any. And we can do the security on the other side. Access list, VTI 10_2. Inside, extend permit IP any. And then we'll apply that to the interfaces. So access group, inside to _VTI 10. And we will put that inbound on interface inside, and access group VTI 10_2 inside. inbound on the interface VTI 10. That should give us our tunnel interface, our security, our crypto for the tunnel interface. So we protected our tunnel interface with encryption. We've put a policy on the ASA side saying that, hey, any traffic that's from the inside interface can go to the tunnel interface. Likewise, anything coming from the tunnel interface can go to the inside interface. So think of it like a virtual Ethernet. Now we just need a route. So route VTI 10 192.168.1.0 is available via 169.254.43.1. Show crypto IPsec SA. So that is up. Our tunnel is up. So tunnel is up. Outside interface, destination interface. Okay. Show crypto IKEv2 SA detail. So phase 1 is there. It's ready. It initiated the connection over to the Palo AES 256, SHA-256, Diffie-Hellman group. And we're using a pre-share key. If we look at the Palo Alto side and hit refresh, we can see our tunnel has turned green. So we have a tunnel. So our phase 2 tunnel is there. And there we go. We can see that it's not using proxy IDs. It's basically routed. So it's like any traffic can go down it. The only thing that's stopping traffic going backwards and forwards is via the policy on the Palo side, because we've done an any on the AES on the ASA side. There we go. It's going via the tunnel for that network. Okay, let's check that. Diffie-Hellman group 14, AES SHA-256, and its role was the responder, which was correct. So now we should be able to go to router 5, and I should now be able to ping from 192.168.1.10. There we go. So I've now got traffic going from my side here to this side here to router 4 via the tunnel. Now let's just double check that that is going via the tunnel. So let's capture one of our internet router legs. We'll see that, yes, there we go. We do have ASA KPM, Internet Security Key Management happening there. So there is traffic going backwards and forwards between the ASA and the Palo for the VPN tunnel. They're doing their key exchanges. That is all functional. So now let's send some data across. So we'll send those ping packets again. And there we go. We can see that they are encapsulated inside an ESP packet. So the traffic is encrypted. So that ping traffic is encrypted. We're seeing CDPs on there, which we shouldn't see because the internet router is running CDP. So no CDP. You wouldn't run CDP on any internet facing gateway. So we'll turn that off so we don't have that showing up. But yeah, the traffic between our private networks from 2.0 to 1.0 is encrypted through a tunnel, through the VTI 10 tunnel on the Palo Alto and the VTI 10 tunnel on the ASA. It is encrypted and the traffic is flowing. Let's just double check we don't have any fragmentation or anything like that for the traffic. Nope. No errors. No packets are being fragmented. Traffic encapsulated, traffic decapsulated. So that is all functional on the ASA side as well. You can see the path and the MTU. Okay, so that's all functional correctly. 256 SHA. Perfect. Okay, so that's all good. So let's just test that if router 5 sends, say, a ping to 8.8.8, we should see that in the capture because that's going directly via the internet, the unencrypted side. Oh, actually, it's not going to hit that because we're monitoring that one. So let's monitor this side as well. So G0/0. So we'll monitor both sides. And now we should see if the traffic goes from router 5 to router 4. That's encrypted. That's going via the tunnel. So anything on the internet, even if there was a man in the middle, they can't see it. And if they ping to the internet, there we go. We can see the traffic going to the public side, which is not going through the tunnel and going directly out onto the internet. So that is all functional. So next, I want to add a subnet and make it reachable. So I need 4.0 and 3.0 to also become available because at the moment, so on the ASA side now, it should just be a very simple case of, because this side is configured with allow anything from the inside interface going to the tunnel interface to allow it. And all it is a route. We should now be able to just add a route on this side. So route and say for VT10 and say 192.168.4.0 is available via 169.254.43.1. Show run route. So now on this side, all we're saying is, hey, this network is now available via the tunnel. And then if we jump to our Palo side, we're going to add a route as well. We're using statics, so we need a virtual router. We're going to add a static route and say 192.168.4.0. So 192.168.4.0/24 is available via the inside interface. And it is on address 192.168.1.10. It's behind that gateway. Okay. And then because this side we've got policies, I'm also going to allow 192.168.4.0/24 to access 2.0, and I'm going to allow 2.0 to access 192.168.4.0/24. And I'm going to commit that. Once that commits, we're going to do that same test again. We'll send traffic from router 5 and it should get a response. Okay, so that has committed. So on the Palo Alto side, we've updated the policy now to allow this side 2.0 to access this additional subnet. So now let's bring up the capture again just so that we can watch. Now let's send that to 4.1. We get a response. And again, traffic goes via the tunnel. Perfect. So that's working. So now if we were on router 4 and we do a ping 192.168.2.10 with a source address. Ping 192.168.2.10, and I want to set the source as L1. So that's not being allowed. Why is that? So we are making it to the tunnel. So we're allowing the traffic to come from the source of 4.1. It's making it, it's hitting the rule. And it's being allowed. So let's have a look at the ASA side. Okay, I think I've got a typo on the inbound on my policy there. Let's just double check that. So let's remove that, and then we'll do access group. That in interface VT10. We're on router 4. There we go. So that's why you should make sure that you kind of stick to a nice naming convention for your access list. So I messed up there. I said that's a 2 and a 0. So I've mistyped that. So actually we should correct that. So that should fix that. Double test again. So now if I ping, yes, so router 4's source address here can now make it over to this. Now let's make this network reachable. So from my side on the ASA, I shouldn't have to do anything, because if we do a show, oh, actually we will do show run route. So I will have to say route inside 192.168.3.0 is available via 192.168.2.10, which is correct. I shouldn't have to make any other changes on this side. And then on Palo side, I should just have to add a route. We will add 192.168. What was it? 3.0. So 192.168.3.0/24. That, from our point of view, is available via the tunnel going to 169.254.43.2. Yes. I didn't just 3.0. 192.168.3.0/24. Tunnel 10. 192.168. No. 169.254.43.2. And then we just update our policy to allow, let's just say from our perspective, we only really want to allow it to access the 4, and we don't want to allow that outbound. So we're not going to initiate any traffic from our side to there. So we're going to allow 192.168.3.0, so it's 24. So we're going to allow 192.168.3.0 to access 1 and 4 only, and 1 and 4 will not be initiating any traffic back over to that side. So let's let that commit, double check that we can reach from 3 to 4 and 1. There's this one here. Now let's send using the address of L 3.1. There we go. We can ping to 4.1, and using that address, we should also be able to hit 1.10 because we allowed that. That's correct. Now router 4, if I try and ping 192.168.2.10 with the source address of, let's start with G0/0, that works. Can I hit 3.1? No, I cannot, because again, I didn't allow it at the moment. So that's good. Control 6. And now if I do with a source address of L1, can I hit 2.10? I should be able to, because we did allow that. Yes. But can I hit 3.1? Should not be able to, because I didn't allow it. Perfect. So there we go. So hopefully, that should help you understand how we can create a tunnel that is not policy based from the Palo Alto to the ASA, albeit an ASAv or a physical ASA. Why you would be wanting to run any of those nowadays, because we are working as hard as possible to get rid of them everywhere I go. But sometimes needs must. But at least now moving forward, the ASA doesn't have to do as much work. There's no more IPsec ACL selectors having to be in place that increases any of the lookup times. There's not as many like cycles being used on the ASA to perform that function, to figure out which sort of packet should go down, which of the tunnels it creates based on the proxy ID. So with now the routed one, all of the packets are just routed. So it's based on what's in the routing table. As we saw, we just have to add a routing table entry on the ASA side. And obviously we're doing the security aspect on the Palo Alto side. We're saying, hey, anything coming in from that tunnel interface, you can and cannot access these addresses. So that's easier for a single place to do the inspection and the rule-based. And obviously it's lighter and faster per packet, because it's just looking at the routing table on the ASA and going, hey, you want to reach that subnet, send it down the tunnel. So hopefully moving forward, that should lighten the load on that ASA whilst I look to remove it and replace it. So VTI, simpler, faster, lighter on the CPU on the ASA. It's route based rather than policy based. And that's what the Palo Alto would much rather be handling. So moving forward, that's what we will do whilst we look to rip out that ASA and replace it with another Palo device. So I hope you enjoyed that. If you did, hit the like and subscribe button, and I'll see you on the next video.